Welcome to the next video in network science. I believe this is video 6. In this video, I think we're going to finish off this practicum number 1. So we're moving from problem 4 to problem 5. And in this problem, we're going to create small networks. So we will create a network from 2 CSVs. Okay. Probably, I'd be at least curious to see what these CSVs actually look like. So if I look at what's in my directory, and they're the got character got relation, so I think I'll vim got relation, I think is the first one. Okay, so a very long thing, but source destination rel type. Okay, interesting. And I guess the numbers are like numbers of, yeah, so I guess these would be like sort of pure indices, I think, is basically the idea here. Anyway, kind of interesting. Let's now quit this and then vim the other file just to see what we're working with. Right, so the other things were pure indices, and I think here possibly these indices are the same as the indices in the other file, but they are associated with more information about each index, like the name of the character, some kind of house something or other, I guess alive or dead, fair enough. Interesting to know about any person, if they're alive or dead. And I guess there might be, oh, I see, and then like up here, there. Up here, we can see what all the categories are. So character, name, group, house, birth, house, marriage, status. Okay, so that's what the CSV looks like. I think my curiosity is satisfied. So what are we going to do? Right, oh right, we are going to import this data, and so it says to do, okay, first got relationships. So, right, so we want to import this data, and so that would be got relationships. Looks fine. Says select source node, source and dest. So source node, dest, target node, edge attribute, which, yeah, okay, looks good. Edge attribute, fine. I think that's all I have to do. Okay, looks good. Okay, now we import the node attribute, so table from file. Oops, that's probably, oh, what about this? Is this, yes, import table from file. And then, so this would be got characters, and use character name as the character, oh wait, sorry, I'm in the wrong place. Use this file, import data, node table columns, I think that's that right there. First column ID should be the key. Oh, it looks like, yep, that's already done. And the other column should be attributes. So attribute, 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 attribute. Okay. I think that's all I do. Looks like, I think maybe that worked. Okay. Now we style it. Use the character name as the node label. Presumably this would be done over here. I want the node label. Why is this? Oop, there we go. Okay. So I guess that must be this. Character name. I don't. What? I think that's what I want. Character name is node label. Yeah, that seems like that did the right thing. So, okay, good. Use the degree as the size of the node. We'll need to run network analysis first. Okay, let's do that. Good. Now I can use the size of the node. So I want to look for size, but it says Check the dependency lock node width and height. Okay. And now I can edit the size and use the degree. This seems like it would be continuous. Seems good. I think that's good. Looks like it worked. Okay. Use the house birth attribute to determine the shape and color. Okay. So let's look at shape. And what was it? House name or house birth? Yeah, okay. And didn't do anything. Okay, what happens if I say discrete mapping? Okay. Still not doing anything. Default values. That okay. So this is tedious, but I guess I'll just say that I don't know how long I'm gonna do this before I get tired, but and also run out of shapes. I don't see that change showing up anywhere. But maybe, okay. Well, that changed. So, okay, and that changed. So maybe they're just rare or something. I don't know. Okay. Okay. But I'm out of shapes, so I might as well go to color. And label, no, I don't want label color. I want fill color. So value, this was the house birth, and then don't really know what some of these things are. First color show, only colorblind friendly, color sequential. Um, it still doesn't do anything. They're all the same color. Okay, so I get just doing this discrete thing is tedious. I'm only gonna do a few until I get a sense of what's going on here. Okay, well that did something. And a lot of these don't seem easy to distinguish. Okay, well that's nice. All right, so anyway, I get the point. So we're just gonna color every single thing. Kind of tedious. Sure hope there's some smarter way to do the mapping. To bypass, what do they mean bypass? Well, I don't think I am interested in that. Anyway, so hopefully there's some smarter way to do it than to set the color one by one. But seems to get the point across that some of these nodes have different house births. Which is pretty cool. I like that you can edit the graph in these pretty ways. That's very satisfying. So then use the relation attribute to label the edges. Leave edges in color black except for edges representing killing, which should be in red. Okay, so I guess we have to come down here to edge and label color. No. Stroke color unselected. So, What is the relate? I think the relate isn't the relationship the relation the killing thing? Yeah, okay. And so everything should be black, so maybe I'll set the default RGB, set it down to that. Not exactly sure how these sliders work entirely, but I guess I'll do that. I think that looks good. Okay, so the default is black, which seems to have taken hold. Good. And then they wanted represents killing. So I think that's this one, which should be red. And so I guess I'll select that. Uh-huh. Okay. Looks kind of neat. I like that. Okay, so I think I did. Okay, so include the graph. Great. If I completed it entirely, I would then export it. Select and extract a graph containing one clique of 4 or more characters. Indicate which characters are involved and style the edges. All right, I want a clique of 4 or more vertices, right? Characters. Ooh, this looks like one, right? Just by inspection, which I kind of hate to have a non-systematic way of doing things, but if I've got it, yep. So this right here would be a clique, right? Everything is directly connected to everything else, 4 or more, because it's 4. So yeah, okay, that's what I would select. Would love to know if there was a smarter, more systematic way of identifying clicks, but in any case, okay. Style the edges so that they show the, so I would export that, style the edges of the relation between the characters. So, I think we've seen enough about how to do that, kinda, so I'm gonna leave that as it is. Show 2 examples of a multi-edge in this graph, which I think this is not the subgraph, it's the whole graph. Okay, this looks like a yeah, so this is a multi-edge. Okay, any other, and another multi-edge, so there we go, 2 multi-edges. Indicate which characters are involved, extract the corresponding subgraphs. I think we've seen enough about how to do that, so I'm not going to go through that in detail. Describe any observations you can make about how the node attribute house of birth is distributed in the graph. One would guess that vertices with lots of connections would be of the same house of birth, I guess. I'd have to really go through the whole process to be able to comment on that at all. But yeah, so anyway, I think I get the point. So now create, okay, so this is interesting. Now create a network on your own using CSV files, which we've seen already. Again, I don't think I'm going to actually do this, but it is nice to know that we could, right? So if I, again, vim, one of these things, you just make a CSV with a title and some vertex indices, possibly a label on, right? So this would be like 73 points to 11, right? Whatever node 73 is and whatever node 11 is, 73 points to 11, indicating, I guess, that 73 killed 11. And there's this other rel type, which who knows what that is, but right, it's just interesting that you could build your own graph from a CSV in this way, in this very efficient way of specifying from which node to which node. You'll need 2 CSV files, one for the network, one for the attributes. So yeah, so this would just be for the network, and then the other one would tell me like the name of index 73 or something like that. Should have between 20 and 30 nodes. Yeah, okay, fine. Especially because I'm not going to do it, that's fine. Then some ideas. Nodes can be bands and so on. Nodes can be characters in a movie. Countries, connections if they share a border. Okay. Note that edges can also have attributes indicating the nature of the relationship between the nodes. Yep, got that. These are only ideas. Tip include a legend, and you can use the legend creator, which I might look into if that ever becomes important. Describe the graph. Include two tables with the contents of the CSV. Draw the graph and include it in your report, and then blah, blah, blah. Okay, cool. So I think that's it. I think that's the end of the first practicum. In the next video, I think I'm going to return. In fact, I am sure that the right thing to do next is to get back to the lecture notes. So I'll finish up the first week's lecture notes. Probably I'll try to, in the future, do things in the right order. And so I'll finish up this week's lecture notes. And then in the videos that follow that, I will do the next week's lecture notes, both of them, before doing that week's practicum. All right, see you in the next video.